Hi guys, welcome all to the Mosfet lecture series. So let us try to figure out the answer for the given question. So in this question, if you observe, given it is N Mosfet W by L equal to 2, VDD value equal to 2 voltage, mu N Cox value is 10 microampere per volt square, threshold voltage is 0.5. Find the value of Vn when Mosfet switches from saturation region to linear region. See, till now we have been solved the question either in linear region or saturation region. What is this? Here this question is we have to calculate the value of Vin. Vin means what? From the diagram if you observe, Vin is nothing but gate voltage because Vin is given across gate terminal. So we have to explore the value of gate voltage when the MOSFET is switching this region from saturation to linear. Now let us start getting the solution for this. Here I wrote something. See there. We know the basic characteristics of MOSFET. Whenever MOSFET switching is region either from linear to saturation or saturation to region linear, the condition is the value of VDS must be equal to the value of VGS minus VT. That is the thing that you have to remember. So it doesn't matter whether we are going from linear to saturation or saturation to linear. Always during the switching point, the condition is the value of VDS almost equal to the value of VGS minus VT. So first to take this condition, keep it in your mind. Then so whenever they are talking about the switching problems, like they are switching the region from linear to saturation, saturation to linear, that is the first step that you have to do. Next thing is you have to identify the equation for drain current. Sir, here if you observe, MOSFET is initially operated in the saturation region, that is what they told, and then it will be shifted from saturation to linear region. So when the moment you are switching the region from saturation to linear, I am asking you, can you change the value of drain current immediately? No, it is not possible. MOSFET inherently having some capacitance property. So the current that is flowing through the MOSFET will not change instantly. So what is the conclusion is, during the switching operation, when you are switching the region from saturation to linear, the drain current will not change instantly. So while solving the question, you can directly take the drain current equation of saturation region. So in saturation region, you know what is the expression for drain current? This can be written as mu n Cox omega by L divided by 2 into VGS minus VT whole square. Yes or no? I hope you all know these things. Yes sir. So the next thing is, let us see. From here you have to substitute all the given data. Now go back to the question, collect all the data from the diagram. From the diagram, first conclusion is, if you observe the source terminal, the value of source voltage is 0 because source terminal is connected with the ground, and gate voltage equal to input voltage, drain voltage equal to output voltage, because across the drain we are observing the output voltage. Next thing is, we can also write the one more expression for drain current. Try to collect all the given data because we have to calculate the value of gate voltage. Gate voltage is nothing but input voltage when the moment we are switching the operation. See there, already I wrote one equation for drain current. Now we can also write one more equation from the circuit diagram. How can we write? See, I just wanted to know the voltage drop across this 10 kilo ohm resistor. So this can be written in two ways. One is by finding the potential difference between the terminals of the resistor. The terminals of the resistors are VDD and VD, equal to, the alternative way is by using the drain current and resistance value. So from here we can write one more expression, ID is equal to VDD minus, sorry, this is VD, right, this is VD upon RD. That is the another way of expressing the drain current. Now take this one as the equation number 2, and we also have one more equation. Don't forget, we are in switching region, so this one will be considered as equation number 3. By using these 3 equation, we can easily solve the switching whenever your MOSFET will be given with the switching region, right? So you have to use these relations in order to break the question. Okay, now substitute all the data. First thing is, I found the switching condition. So here I need to know the value of VDS, VGS, VT, everything. So let us see how to do that. Take your question. Now tell me, what is the value of VDS? from here, VDS can be written as VD minus VS. What is the value of VD? VD is nothing but output voltage, Vs equal to 0. Simply it can be written as V0. Yes or no? See there, this is VD, VD equal to V0. Similarly, if you write the expression for VGS, it can be written as VG minus Vs. Similarly, the value of Vs is equal to 0 and Vg equal to input voltage Vn. Just now we have explored. Next, if you are trying to explore the value of VDS equal to VGS minus VT, we can say VDS can be replaced by V0, VGS can be replaced by Vin, VT is already given in the question, that is 0.5. Treat this one as your equation number 4. Vt is already given in your question. See there, it is already given here. The value of Vt equal to 0.5. Now, take the next equation, that is your drain current. Substitute all the data. Mu and Cx is given as 100 microampere. So, 100 into 10 power minus 6 by 2 into W by L is given as 2 into VGS is nothing but your input voltage Vn minus Vt is 0.5 whole square. Now treat this one as your equation number 5. You can also cancel this 2 if you want further. Okay sir. Next, this 100 into 10 power minus 6, what you will be getting? It will become 100 into 10 power minus 6 means 10 power minus 4. So let me write one more step better. Vn minus 0.5 whole power 2. Treat this one as your equation number 5. Skip the previous one. This is not required. Okay sir. So this is one equation. We also found one more equation for ID. Yes, where is that? Go back to that expression. VDD minus VD by RD. VD is given. Value of VD is 2 voltage. Okay sir. VDD is nothing but output voltage. Okay sir. RD is equal to 10 kilo ohm. Now substitute all the expressions in order to write the another expression for ID. So let me write the value of ID can also be written as VDD. So VDD minus VD by RD. Shall we start writing this? What is the value of VD? Sorry, the value of VD is given as 2 voltage. Sir, VDD is given as 2 voltage. Let me write it here. So 2 voltage minus VD is nothing but V0 upon RD is 10 kilo ohm, that is 10 into 10 power 3. Further, this can be written as 2 minus V0 into, can I write 10 power minus 4 here? How it came? See there, 10 into 10 power 3 will give you 10 power 4. If you bring it to the numerator, it will become 10 power minus 4. Now, you can take this one as your equation number 6. Next, what you have to do is, see there, equation number 5 also ID only, equation number 6 also ID only. Now, I am giving you a small task. Just equate these two expressions. And one more thing, what you need to do is, replace this Vn minus 0.5 by V0. Am I right? From this switching equation, see there, I have already derived that V0 equal to Vn minus 0.5. So, if you replace it, further what will happen is, when you are equating 5 and 6, let me write, if I am equating equation number 5 with the equation number 6, it will become 10 power minus 4 into V0 square equal to 2 minus V0 into 10 power minus 4. This 2 will get cancelled out. Further from here, sorry, not this V0 square will not cancelled. 10 power minus 4 will get cancelled. Now if you observe V0 square plus V0 minus 2 equal to 0. We have been observed one second order quadratic equation. How will you solve this equation further? In order to solve this question, you have to use your mind. You know the basic formula. We cannot directly break these roots. So for that, I am using the quadratic equation formula, or you can also directly say that, see, this, if I will break this roots into 2 off, can I write this expression as the value of V0 plus 2 into V0 minus 1. If you expand this, what you will be getting? You will be getting V0 square, okay, plus 1 minute, 2 V0 and minus V0. So, it will become V0. Yes, I am correct. So, what we will be getting is, it will be again giving us again V0. See there, 2 times of V0 again minus V0. At last, you will be getting minus 2. So conclusion is, from here directly I can say the value of V naught equal to minus 2 voltage comma the value of V naught equal to plus 1 voltage. Sir, we got 2 voltages for V naught. Which one we can take, sir? Now you have to decide. Basically we are trying to switch the region of the operation from saturation to linear. Yes or no? Either your MOSFET will be in linear region or it should be in saturation region. That is, the two regions will be allowed. Suppose if you are selecting the value of V naught equal to 1 voltage, let us see what will happen. You know V naught is nothing but Vd. Yes or no? Yes, sir. Now what is the relation? We know the value of Vgs minus Vt is equal to the value of VDS. But from here we have been observed that the value of VDS can be simply written as VD, VGS can be written as VG minus VT. We also found that this VD is nothing but V naught, right? So VD equal to VG is nothing but input voltage Vn. So let me explore everything, don't worry. Let me write it in terms of VG only, such that you will be understanding easily. What will happen here, sir? That is the question. What will happen? Vg minus Vt is 0.5. If I will substitute Vd equal to 1 voltage here, what you will be getting? If Vd will become 1, then Vg will become 1 plus 0.5. Just to pass that minus 5 to the left hand side, it will become 1.5 voltage. So what is the conclusion? The value of VGS. See, Vg, VGS both are equal. Why? Because Vs equal to 0 here. So VGS is greater than Vt. So this is the condition to operate the MOSFET either in saturation or linear region. Suppose if the value of VGS is less than Vt, then the region of operation will be cutoff region. So from this I can say, okay, in order to operate our MOSFET either in saturation or linear region, the value of V naught should be 1 voltage. Now you can check. Suppose if you are taking V naught equal to minus 2, then what will happen? We know Vd equal to Vg minus Vt. If I will substitute minus 2 here, minus 2 equal to Vg minus 0.5. This will give you the value of Vg equal to minus 1.5 voltage. Yes or no? If you pass this minus 5 to the left hand side, it will become plus 5. Minus 2 plus 5 will become minus 1.5. See, Vg is nothing but Vgs. So it is clearly indicated that the value of VGS is minus 1.5 and whereas the value of VT is 0.5. So VGS is less than VT. It means region of operation will be cutoff region. MOSFET is off. It is in off state. So this voltage is not valid voltage. So the correct answer is the value of output voltage is 1 voltage. If output voltage is 1 voltage, then what is the input voltage? Already we found the answer. See there, VG is nothing but input voltage. Yes or no? From here I can say the value of Vg equal to Vd plus 0.5, Vd is 1, so the overall answer will become 1.5 voltage. So what is the correct answer? Input voltage Vin is equal to 1.5 voltage. I hope you all understood. So in our today lecture, we understood about switching region. So when we are switching the operation from linear to saturation or saturation to linear, how to solve this question further. That is what we understood in our today lecture. So this is all for this lecture. Remaining things we will see in the next class. Thank you all.